Okay guys, so here's the deal. We're going to do a quick example again together. We're going to take a written scenario and we're going to convert that to the different types of motion maps. We're going to start with ticker tape, then go to position versus time, and then to velocity. We're not going to pay any attention to this whiteboard behind us, but just to this one right here. So our scenario is Dad is 7 meters from the couch. He begins to walk towards the couch at 2 meters per second for 2 seconds. Then he gets distracted and he stops for 2 seconds. He continues again at 1 meter per second until he reaches the couch. So we know from looking at that we need to have 7 meters on our ticker tape. So here's our ticker tape right here. I have it set up and I have it with 8 meters right now. And so the first thing we want to do is we just want to start plotting those points and do what it tells us to do. So it tells us that the first step that Dad walks 2 meters per second for 2 seconds. Now he's starting 7 meters away from the couch. So we're going to start right here at 7 meters. Remember, 1 dot equals 1 second. We're going to start at 7 meters and we're going to go for 2 seconds at 2 meters per second. So if I'm going 2 meters per second and I'm starting at 7, my next second will occur at 5 meters and then again at 3 meters. And then it says that he stops for 2 seconds. So 1, 2. His distance has not changed because he's not moving, but time still happens. Time can't stop. Okay, he's got it back together. His favorite show's coming on, so he's going to keep going towards that couch at 1 meter per second until he hits it. So if we're at 3 meters at this point, his next one will be 2, 1, 0. And then we have to add our arrows because that lets us know that there is motion and the direction of the motion. Now, the next thing that I do is I go and I count my seconds. We're going to start with 0. Because between this dot to this dot, 1 second occurs. 1, 2, 3, 4, 5, 6, 7. Now at this point, I like to go and I like to plot my coordinates so I know what to do and I'll plot them on my graph. You have to remember your x coordinate is going to be your time and your y is going to be your distance. Okay, so my first second is going to be, or time interval is going to be 0, and at 0 I'm at 7 meters. At 1 second I'm at 5. At 2 seconds I'm at 3. At 3 seconds I'm at 3. At 4 seconds I'm at 3. At 5, I'm at 2. At 6, I'm at 1. And at 7 seconds, I'm at 0, or he is at the couch. Now we're going to take this data and we're going to take it to our position versus time or our distance versus time graph. In order to do that, we have to make sure that we have a minimum of 7 meters on there, and we have to have at least 7 seconds. What are the chances of that? So I'm just going to come right down here, just like this. I'm sure this will get it. Make sure you label your axes, and this is going to be meters. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you're doing seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And then we'll plot my points. My first one is 0, 7. So that means at 0 seconds, I'm at 7 meters. That's my starting point. And then I go to for 1 second, I'm at 5. At 2 seconds, I'm at 3. At 3 seconds, I'm also at 3. At 4 seconds, right here, which is right here, I'm also at 3. At 5, I'm at 2. At 6, I'm at 1. And at 7 seconds, I'm at 0. 0 meters. 7 seconds. And then I want to connect my dots. And sorry, I don't have different colored pens at home to try to show this better. But if we look at this, we see that just from looking at it, we have a negative velocity or a negative slope because the slope is going downward. We also know that we have 3 segments. I'm going to call this segment A, this segment B, and this segment C. And now we have to solve for the velocity of each of those segments. To do that, we're going to come over here and we use the slope form of rise over run, which is also distance over time, just so you know. And we look. For segment A, we went from 7 meters to 3 meters. So we went a total of 4 meters. But we're going down, so I'm going to make that a negative 4 meters. And that occurred over 2 seconds. It's from 0 seconds to 2. So negative 4 divided by 2 gives me a velocity of negative 2 meters per second. Segment B, when we have this flat horizontal line, we know that is a 0 slope, which also tells us we're not moving, but time is passing. So that gives us a velocity of 0 meters per second. Segment C, rise over run. Segment C begins right here at 3 meters and it goes down to 0 meters, from 3 meters to 0. So if I'm going from 3 meters down to 0, that means I'm going a total of negative 3 meters. And that happens over how many seconds? That's our run. So I come right here. Here's 1 second, 2 seconds, 3 seconds. So negative 3 divided by 3 gives us negative 1 meter per second. Okay, so this is where we are. We went from a written description to a ticker tape representation to position versus time. Now we're going to have to put this on a velocity map or velocity graph. To do that, I'm just going to pull this way to make it easier for me. I'm going to do that right here. And a velocity graph looks something like this. This right here represents meters, meters per second. Okay? And then this right here, this line, the horizontal line, that is our seconds. I'm going to start there. I know that I have 7 seconds that have passed, so I'm going to put 7 or more ticks right here. 1, 2, 3, 4, 5, 6, 7. Oh, that's perfect. 1, 2, 3, 4, 5, 6. And then I'm just going to make this a positive 1, this a positive 2. Then I'm going to come right down here. I'll make this a negative 1 and this a negative 2. Okay, so we've got our little graph area set up. Now we have to look at the velocities we solved for. For segment A, we decided that it had a negative 2 meters per second velocity. Segment A happens between 0 seconds and 2 seconds, right? So right here, between 0 seconds and 2 seconds, I need to come down to the negative 2 and put this right here. That tells me that between 0 seconds and 2 seconds, my object or dad was moving at 2 meters per second. If I look at segment B, that happens between 2 seconds and 4 seconds. Now, your segments over here cannot overlap, but time doesn't have any gaps in it. So we have to begin this at 2 seconds and we have to end it at 4. So from 2 to 4, right here, is going to be segment B. And segment C is going to be -1 meters per second. And segment C is going to start at 4 seconds and ends at 7 seconds. So we need to come over here, and at -1, here's -1, we need to start at 4 seconds and end at 7, and we'll call that segment C. And that gives us the whole scenario from start to finish. We went from written to ticker tape to position versus time to velocity. Hopefully this helps give a little better understanding.